Hey folks, in this video I want to discuss a basic ADT for representing a directed graph. So this is what we've been doing for a while now, right? We've been basically talking about data structures, we've been proposing ADTs or APIs for representing them, right? And then figuring out how to implement them. So we're just going to do the same thing here. So what we're looking at is pretty much inspired by the ADT for using normal undirected graphs. But there's been maybe a few minor changes. So let's take a look. What's changed since the previous kind of implementation of this? Well, obviously the name is different, right? But that shouldn't shock us too much. Obviously, we're representing a different type of graph, right? We're representing a directed graph. So instead of it just being called graph, it's called digraph. So that's not a big surprise. Let's see, looking down, this stuff looks mostly the same, right? So two constructors, we had that in the normal graph stuff as well. V and E, right? We had that in the previous implementation as well, right? All that stuff's pretty good. We had to add edge as well, right? And add edge, at least in terms of the function or method that's shown up on the screen, that looks the same. Right, the function name or the method name is identical. What's different though is that I have this notation over here. Notice that the comment says add edge V arrow W, right? So that's actually kind of where our directness has come in, where it's saying, oh, hey, we're going from V to W, right? So now the directionality matters. It's not before where it's like, well, I have V and W, I'm just going to connect them, right? So that W is related to V as well. Here we're explicitly saying it goes from V to W, right? There's only one direction because this is now a directed graph, and so that's what I need. That's my additional constraint, right? I can only have my edge going in one direction. Okay, so this is actually one of our big differences here, right? So this thing here, and it's not really even in the method signature, right? It's rather in the documentation for what is it that this method is doing. Okay, so ADJ, this is another one that basically is coming from the undirected graph ADT. That's going to use the nodes that are adjacent to the one that we're like looking at, right? So that's pretty much the same. Nothing really different there, right? Let's see, reverse. Reverse is brand new. Reverse, we won't be using it too much for us. It does kind of provide for some interesting algorithms later on. Basically what it is it's a way to basically get a new version of this graph where the direction of every edge has been flipped, right? So obviously, right, typically going from V to W, right, for example, right? Reverse returns me a new graph where every pair, right, from V to W has been flipped, so now it goes to W to V, right? So we just reverse all the edges in the graph. And this actually gives us some interesting stuff. We're not going to really need it in this course, but it's something that's very typical for other graph algorithms, right? So we're going to go ahead and talk about it just a little bit. All right, so these are kind of our major changes here, right? Our add edge is a little bit different. Our reverse is brand new. So a quick question for you guys. I'm thinking about this. Would it make more sense for us to maybe, would it make sense to use, for example, adjacency matrices here or adjacency lists? Will both of them work? One of them work? Any thoughts here? Take 1 second and just think about those data structures we know about, right? Matrix versus list for starting a graph, right? How will they fare in terms of a directed graph, right? We've seen them for undirected, but how about a directed one? So both of them will kind of work out fine, right? Adjacency matrices will also be a little bit nicer than they were before. Before there was this issue where it's like, well, if I have a directed graph, if I have a undirected graph, right, my matrices would have, some sort of a symmetry to them. I'm trying to think. So like, it's like if there's something over here, there's something over here, if something over here, there's something, that type of deal, right? And so it ends up being that you have half of this, it doesn't really make any sense, right? That'll kind of go away and it'll be a little bit better because it's like, well, I now, if I have an undirected graph, right, it's not always implied that I'm, going to be connected in, both ways, right? Maybe I'm only connected one way. So it'll be actually a little bit more efficient to use matrices, right? Normally we have this issue of symmetry because anytime I can go from, V to W, I can go from W to V, right? So both these sides end up looking the same. Now for a directed graph, right, we're going to have to be more specific, right? We're only going to go from V to W, right? It's not implied that it goes from W to V, and so these will no longer be symmetric, okay? So it's actually a little bit nicer to use matrices, although matrices still have the issue of they're very large, right? They require O of n squared amount of space, so a little bit questionable there. Adjacency list, right, would be another choice. Adjacency list, basically, there's not really a whole lot that's different than for a directed graph. I guess the only thing really is that when you go and you do your adjacency list, right, whenever you add a new node, you're not going to have to update, two different lists, right, with different nodes, right? You don't have to do that. You only have to update one of them, right? So it's like, well, I don't have to update both of those. Just, throw a new one in here, right? So maybe it's even a little bit of less work to do, right? So yeah, either of those are fine. For us, we'll kind of stay focusing on adjacency list just because it's more kind of a more compact representation, right? It takes less space. So we are going to stick with the adjacency list representation. All right, so that's all I got for you guys in this video. In the next video, we'll take a glance at the code for actually storing a directed graph.